Kia ora koutou. In this video, I'm going to go through question 1 from the 2021 Level 2 Probability exam. And I'm going to go really slowly and talk about how we can interpret tables and use them to solve probability problems. So if this is too slow, just put it on to double speed. I've gone all the way through this question right up to the end, even though it covers some stuff that we haven't completely done in class yet. But that's just the last part of question B. So in here, this bit here is a thing that we're going to do in about a week's time or maybe 2 weeks' time. Okay, so let's go all the way back to the start. As usual, there's quite a lot to read here, and I'm going to go through that pretty slowly. So New Zealand is well known for its cafe culture, and the availability of coffee has increased significantly over the last 20 years. However, there's growing concern that teenagers are consuming more caffeine, with potential negative effects on sleep behaviours and performance at school. Okay, a school was concerned about this issue and conducted an online anonymous survey of 300 of its senior students. And it asked if students drink coffee regularly, at least 3 times a week, and if they have any sleep-related issues. The results are summarised in the table below. So notice that I've got 2 things going on, which is why a table makes good sense. The first thing is the coffee. Do they drink it regularly or not? And the second thing is, have they got sleep issues? Okay, so like insomnia and things like that, or waking up. And you can see in the table that the 300 students in the survey are here, right? So then we have different cells that tell us different things. So if we're in this row here, these are the people who drink coffee regularly. We can see there are 122 of them. Some of them have got sleep issues, so 68 have got sleep issues, but 54 don't, and so on. Okay, so we need to be careful with how we interpret the questions here. So these are 2 little achieved questions. According to the results of this survey, what proportion of the senior students drink coffee regularly? So I'm going to write that like this, P bracket, and then I'm just going to put coffee. So we're being asked here about what proportion of all of the students in the survey, right? So what proportion of the senior students drink coffee regularly? I want you to imagine that we're putting the names of those 300 people into a hat and their answer to the questions about coffee and sleep. So how many names are going into the hat? Well, it's all of the senior students. So this answer is going to be out of 300. And how many of the 300 drink coffee regularly? So to figure that out, we have to go here. So drink coffee regularly, and the answer is going to be 122. Now, it's actually fine to leave that how it is in the exam. You'll get a tick for that. It looks pretty ugly to me, though, so I would rather simplify it, but you don't have to. Okay, so that is, in fact, okay here. So that's 61 out of 150. But the other thing we can do with it is just turn it into a decimal. If you're going to do that, don't round it too hard. So I would go with 0.4067 here to 4 dp. Okay, that's the first one done. Now, let's look hard at the difference between this question, which is asking about the proportion of the senior students, and this next question, which is asking something different. So this one says, what is the probability that a randomly selected student from this survey who has sleep issues also drinks coffee regularly? So the way to interpret this is think about our hat. Here's our hat, and which names are going into it this time. Well, this time it's not all 300. It's just the randomly chosen students who have got sleep issues. And to find that number out, we look at the sleep issues column and we go down to here. And there are 143 who've got sleep issues. So there are 143 names in that hat, right? Imagine they've all written their answers on a little piece of paper. And we want to know, out of those 143, what proportion have got sleep issues. So the notation that we use for this is what I did in class yesterday. So given that they have sleep issues, what's the probability that they drink coffee? Well, we're choosing out of 143, and now we have to go back to the table. Let's get rid of all the muck. And we're saying out of those 143, how many drink coffee regularly? So that means that they have to do both of those things, have sleep issues and drink coffee regularly. It's going to be 68 out of 143. I can leave it like that, or I can change it to 0.4755. Okay, that's the first part done. I'm not going to get through the whole of this question one in one video. So there'll be a second video for the next part. Right, so we've done that. Let's have a look now at part 3. So I've reproduced the table in here so we can see what's going on. So Jack looked at the data for students with sleep issues and noticed that fewer of them drink coffee regularly. He claims that this means it is less likely for coffee drinkers to have sleep issues than those who don't drink coffee. So let's see what numbers Jack's looked at. Well, he's figured out that out of the students with sleep issues, there are 68 who drink coffee regularly. And he says out of the ones who don't drink coffee regularly, there are 75 who've got sleep issues. So Jack is comparing the numbers of students, right? So let's start by saying that. So Jack is not comparing probabilities or proportions. He's not comparing probabilities. He's comparing numbers, but the number in each group, coffee or no coffee, is different. So that's the first thing to say. And now we want to work out some probabilities to show why he is wrong. So he says it's less likely for coffee drinkers to have sleep issues than those who don't drink coffee. So what I want to find out here is, given that someone has coffee, what are the chances, or what's the probability that they have sleep issues? And given that they don't drink coffee, which I'm going to write like this, so you saw this with Mrs. Galdra on the first day, right? So coffee with a little dash, that means the complement of coffee, or people who don't drink coffee. So we have to work out these two conditional probabilities. They're called conditional probabilities because in this one, I'm just looking at the people who drank coffee in the survey, and in this one, I'm just looking at the people who didn't drink coffee. So let's work out what they are now. So for the probability of sleep issues, given that they had coffee, I'm counting in my hat, I've got all of the coffee drinkers, right? So there were 122 people who drank coffee often. 68 of them had sleep issues. And when you work that out as a decimal, you get 0.5574. Okay, let's just get rid of that there so it's not confusing. So that's my first one. So given that someone drinks coffee in this survey, the probability that they have sleep problems is 55.7%. Now, what about if they don't drink coffee? The probability that they have sleep issues, given that they have no coffee, well, who's in the hat? Let's have a look. So the people in the hat are the ones who don't drink coffee. So that's these ones here, 178 of them, and 75 of them have got issues with sleep. So it's going to be out of 178, and it's going to be 75. So that works out to be 0.4213. Or we could write that as 42.1%. Okay, this one is 55.7%. So let's explain a bit more now about what Jack's done wrong. Why is he wrong? So he's wrong because only 42.1% of non-coffee drinkers have sleep issues. Compared to 55.7% of coffee drinkers. So hopefully what you're seeing is that to do well in the standard, you have to be able to interpret information and then explain why someone is right or wrong. So just going over it again, let's just look at what Jack's claim is and how he's wrong. So he looked at the data and he saw that fewer drink coffee regularly. And he's seeing that by going, sorry, the people with sleep issues, fewer drink coffee regularly. All he's doing for that is he's just comparing a 68 here and a 75 here. And he's saying this number here, the 75, is bigger than the 68. But that isn't fair because that's 75 people out of the 175 who don't drink coffee. Whereas this one is 68 out of 122. So you can see that this one is more than a half and this one is less than a half. So his claim is definitely wrong. I'm just going to show you 1B and then I'm going to do that in a separate video. So in 1B, we're still going to be working with the coffee and sleep issues, but we now have a third variable coming in, which is energy drinks. All right, so make sure you've got that first part figured out before we go on. This bit here was a merit question, okay? And these two here were both little achieved questions. I'll be back with the second half of this later on tonight.